Hello, this is section 2.4 Applications. Applications with linear equations. Example 1, Part A. Jesse has $6.55 worth of quarters and nickels in his pocket. The number of nickels is 5 more than 2 times the number of quarters. How many nickels and how many quarters does Jesse have? So just like in the previous section, we're going to start off by labeling our variables. So we're wondering what are the number of nickels and what are the number of quarters? Which one were we told nothing about? That was the quarters, so that'll be X. And then the number of nickels is 5 more than 2 times the number of quarters. Now, when we write our equation, though, we weren't told the total number of coins. We were told the total worth of the coins. So what we have to do is take the number of nickels times how much a nickel is worth, which is 5 cents, plus the number of quarters, times how many or how much a quarter is worth, and that will equal the total worth. And notice, just so I don't have to deal with decimals, I'm recording everything as cents, not dollars. And now we need to solve this equation. So distribute, we get 10x plus 25 plus 25x equals 655. 35x plus 25 equals 655. Subtract 25 from both sides. 35x equals 630. Divide by 35, divide by 35. X equals 18. So there are 18 nickels, or sorry, 18 quarters, because X represents the number of quarters. And now to figure out the number of nickels, we would go 2 times 18 plus 5, 36 plus 5, which is 41. So there are 41 nickels. Part B. Eric paid $19.88 for stamps. The number of 49-cent stamps was 8 more than twice the number of 35-cent stamps. How many 49-cent stamps and how many 35-cent stamps did Eric buy? So again, starting out by labeling our variables, we have the number of 49-cent stamps, the number of 35-cent stamps. Which one were we told nothing about? The 35-cent stamps. So that'll be X. And then the 49-cent stamps was 8 more than twice the number of 35-cent stamps. And just like in the previous example, we now need to take the price times each amount. So 49 cents times how many 49-cent stamps plus 35 cents times how many 35-cent stamps has to equal the total price. Distribute the 49. We get 98x plus 392 plus 35x equals 1988. Combine like terms. We get 133x plus 392 equals 1988. Subtract 392 from both sides. Get 133x equals 1596. Divide by 133 on both sides. And we get x equals 12. So we have 12 35-cent stamps. And then the number of 49-cent stamps is 2 times that plus 8. which is 24 plus 8, which is 32. So then we have 32 49-cent stamps. Part C. A whale watching ship had 40 paying passengers on board. The total revenue collected from tickets was $1,196. Full fare passengers paid $32 each. Reduced fare passengers paid $26 each. How many full fare passengers and how many reduced fare passengers were on the ship? So again, label our variables. So number of full fare and number of reduced fare. This time we weren't really told much of any of them, so we get to pick which one is X. I'm going to say the number of full fare was X. Well, then how many reduced fare were there? This is where you have to use that first sentence where I know there's a total of 40 paying passengers on board. So if there's X full fare, that means 40 minus X would represent the number of reduced fare. And now we have 32 times the number of full fare plus 26 times the number of reduced fare has to equal the total price. And now we're going to distribute. We're going to get 32x plus 1040 minus 26x equals 1196. Combine like terms. Subtract 1040 from both sides. And we get 6x equals 156. Divide by 6 on both sides. And we get x equals 26. So there were 26 full fare passengers. And then 40 minus 26, which is 14, reduced fare passengers. And that's the end of Part C. Part D. Becca wants to mix fruit juice and soda to make a punch. She can buy fruit juice for $3 a gallon and soda for $4 a gallon. She wants to make 28 gallons of punch at a cost of $3.25 a gallon. How many gallons of fruit juice and how many gallons of soda should she buy? So just like in the previous example, we're going to have gallons of fruit juice and gallons of soda, and we don't know either of them, so I'm just going to let the fruit juice equal X. But I do know we're going to have 28 gallons total, so that means the gallons of soda would have to be 28 minus X. So then, taking the price, so 3 times X plus 4 times 28 minus X, that has to equal the total cost of the 28 gallons, which would be 325 times 28. So don't forget, they didn't give us the total cost this time, so we have to calculate it ourselves, so we have to multiply those together. Now we can distribute on the left-hand side, and we get 3x plus 112 minus 4x is equal to 91. Combining like terms, we get negative x plus 112 equals 91. And we can subtract 112 from both sides. And we get negative x equals negative 21. Divide by negative 1, divide by negative 1. We get x equals 21. So we need 21 gallons of fruit juice. And then 28 minus 21, which is 7 gallons of soda. And that is it for part D. Now for part E, Wayne and Dennis like to ride the bike path from Riverside Park to the beach. Dennis's speed is 7 miles per hour faster than Wayne's speed, so it takes Wayne 2 hours to ride to the beach, while it takes Dennis 1.5 hours for the ride. Find the speed of both bikers. So actually, before we start doing this problem, I'm going to break this problem down a little bit. This type of problem where you're talking about speeds and distances and times are called uniform motion problems. And we use the formula D equals R times T, where D is distance, R is rate or speed, and T is time. Now we can actually encode this formula in what's called a triangle. Where D's on top, R's on the bottom, and T's on the bottom. Now, whenever you cover up one of these parts, that tells you the formula. So if I know what I want to figure out what D is, I'm going to cover up the D. You can kind of see that there. And then we're left with R and T next to each other, so that means D equals RT. But if I want to solve for T, I cover up the T, cover the T up, and then I have D on top and R on the bottom, so T equals D over R. And then same over here, if I cover up the R equals D over T. So it's just a nice way to encode all three formulas in one diagram. Well, once you identify that you're working on a uniform motion problem, I highly recommend you set up this table. And so DRT are your column headers, and then however many rows you have, usually 2 to 3 rows. In this case, we're going to be talking about Wayne and Dennis. And a lot of times you will have a total row. In this specific problem, you're going to notice they didn't give us the total for anything, so we aren't going to use it. So let me just cross them out. Okay. So Dennis's speed is 7 miles per hour faster than Wayne's speed. So that means I do not know what Wayne's speed is, so I'll just put X. But then Dennis would be X plus 7. And it takes Wayne 2 hours to ride to the beach, while it takes Dennis's 1.5 hours to ride to the beach. Now, when you're doing these types of problems, you're always going to be left with a column that is blank. In this case, it is our distance column. Now, what we're going to do here is use the formula to fill this column in. So D, which is R times T, so that means this would be 2x, and then this would be 1.5x plus 7. Now, in this specific scenario, we weren't given the total, but we know they're heading to the same place. So we know the distance they traveled must equal each other. So this is the equation we get from the table. And now I can go ahead and solve for x. So I'm going to distribute the 1.5. Oh, not an equal sign, a plus. Subtract 1.5x from both sides. And then divide by 0.5. I'm actually, though, because it's easier to do mentally, is going to multiply by 2 on both sides. So we get x equals 21. So Wayne traveled 21 miles per hour. And then Dennis traveled, well, 7 more than that, so 28 miles per hour. And that's how you do part E. And now on to part F. So Jeremy can drive from his house in Cleveland to his college in Chicago in 4.5 hours. It takes his mother 6 hours to make the same drive. Jeremy drives 20 miles per hour faster than his mother. Find Jeremy's speed and his mother's speed. So this is almost exactly the same as the last one. So I'm going to set up my DRT table. We're going to have 2 rows because we weren't given any totals. And we have Jeremy and his mom. Don't know how fast the mom drives, so I'll put X. But I know Jeremy goes 20 miles an hour faster, so X plus 20. Jeremy can make it in 4.5 hours, and his mom can make it in 6 hours. Again, we're left with one blank column. We use the formula to fill it in. So we get 4.5 times X plus 20. And then we get 6 times X. And again, they're traveling the same distance, so I take these equal to one another. Distribute the 4.5. We get 4.5x plus 90 equals 6x. Subtract 4.5x from both sides. And we get 90 equals 1.5x. Divide by 1.5, divide by 1.5. And we get x equals 60. So that means the mom goes 60 miles per hour. And then Jeremy goes 20 more than that, so 80 miles per hour. And I think that's a good place to stop for this part of the notes.